Okay, I want to do one more follow-up problem here before we get into some other examples. This is just kind of a basic problem. Suppose we have a quantity that's normally distributed with mean 5 and standard deviation 2. Find the probability that the randomly selected value will be, and then I give you two problems here. So I want to know what's the probability that a randomly selected value will be greater than or equal to 4. And again, just to quickly graph, so this is going to be normal curve centered at 5, 4 is over here. Our answer should be a little bit more than a half. And so again, that just kind of gives us some intuition about what our value should be. And we want to find the probability that this value will be greater than or equal to 4. So what we're going to do is we're going to compute the standardized values. So we'll compute the standardized values here. I'm going to just give us a little bit more space here because I didn't give us enough. And our standardized values are going to be z is, let's see, the value we're working with is 4, mean is 5, and the standard deviation is 2. So this is negative 1/2 or negative 0.5. And what we can do is we can go to the table. We have our table of values, and we can look up where is the value negative 0.50. And so let's see, negative 0.5 is down here. And negative 0.50, so with the negatives, this goes from right to left just because it's negative, so it's backwards. And so we're looking at 0.3085. Okay, so this value here, I'm just going to highlight it just for a second. It's 0.3085 is the first value. And remember what that is. That's the probability that a randomly selected value will be less than or equal to negative 0.5. So if we want to figure out the probability that a randomly selected value is greater than or equal to that, what we will get would be, this would be 1 minus 0.3, what was it, 0.3085. So it turns out that our probability is, so what I'm saying here, just to make this, I should write a little bit more. Oops. So what I'm saying here is the following. I'm saying that the probability that a randomly selected value will be greater than or equal to 4 is 1 minus the probability that that randomly selected value is less than or equal to 4. If you want to not include the equal sign in either spot, that's fine. These technically are not complements, but they'll have the same probability whether you include the equal sign or not. Okay, because the probability that something happens that it's exactly 4, that probability is 0, because we're talking about a rectangle with 0 width. So anyways, so this is 1 minus 0.3085. So the probability that our randomly selected value is at least 4 is 0.6915. Okay, so a little less than 70%. Okay, and that's how we'll use the chart to get that kind of information from it. And likewise, let's talk about the probability that a randomly selected value is between 4 and 7. So one way that we can do that is, again, a picture will just be helpful. We have a mean of 5. And so if we want to find the values between 4 and 7, we're talking about this area here. And so what we're going to do is we're going to take the area up to 7 and then subtract from it the area up to 4. So we need to figure out what are the corresponding standardized variables. So z is going to be 7 minus 5 over 2 because we have a mean of 5 and a standard deviation of 2, and that happens to be 1.0. And then we already know that the other z value is 4 minus 5 over 2, which is negative 0.5. And so what's going to happen is our area here, so the probability that a randomly selected value is between 4 and 7 is going to be, I just want to show you how I'm thinking about these probabilities. This is the probability that the value is less than or equal to 7 minus the probability that it's less than or equal to 4. And then what's going to happen is you're going to take all the area up to 7, subtract the area up to 4, and then you're left with this orangish area, which is exactly what we want. So All we have left to do next is to go up to the table and look up what's the area under the standard normal curve up to 1. So let's do that. So since it's to the right of the mean, in other words, since our standard variable is positive, our value is going to be over here. And if we're looking at 1.00, it's going to be 0.8413. So 0.8413. The probability that x is less than or equal to 4 is what we found previously. That was the 0.3085. And then whatever that subtracts to will be our answer. So if you want to do the subtraction off to the side, feel free to fast forward this part of the video. We're going to get 8, 3, 10, 2, 3, 5. So 0.5328. Okay, that'll be our probability that a randomly selected value is between 4 and 7. I finally want to show you how to do each of these problems with R. So let's go ahead and let's jump over to R here. So let's jump over and let's look at R. And again, there's two ways that we could do this. We could do this with a standard normal distribution. Oops, I have caps lock on. We could do this with a standard normal distribution. So that's going to be the value. Let's find first the value that something is less than or equal to 4. Well, that's the value, that's the cumulative probability up to 4, given that we have a mean of 5 and a standard deviation of 2. And so that was our 0.3085 number that we had. And again, the value up to 4 decimal places is printed in that table. Notice that that's the same as the standard normal up to negative 0.5. But then what we really wanted was 1 minus that. So we really could have just typed 1 minus p norm of 452. And that would be our 0.6915 like we found before. Okay, so that's how we could do that one. And likewise for the second one, if we wanted to find the probability that a randomly selected value is between 4 and 7, we took the area up to 7 minus the area up to 4, and then that difference was 0.5328, just like we found. Okay, so this is one way that we can use R to our advantage here. The R really makes these problems much nicer, much faster, much easier. Okay.